All right. All right. Okay. Seems like the echo issue is fixed. Sorry about that, everyone. So just to reiterate, we are having both projects and workshops in here at the same time. If you're with projects, Pratik and Leon, I think I see you guys up. Is that Leon? I can't tell. My glasses aren't too great. Is that Christoph? Okay, but whatever. They're basically the same person. Go to the back if you're in projects. They have some lovely stuff prepared for you. If you're here for workshops today, thank you for coming back after our kickoff. And we have it'll be a pretty similar format to last time. Breaking out in small groups. We will be having a little bit of presentation action beforehand, specifically about how neural networks work, because we noticed that a lot of you guys are on the MNIST notebook, as well as AI ethics. And that, I know you may want to be like, I don't want to pay attention during AI ethics. Please pay attention. Ethics are very important. So before that gets started, we do have a couple of announcements here. We're putting on an event with Bruin Linguistics, meet the AI and Ling professors. This is going to be a very casual, just sit down, hang out, interact with the professors, ask them questions about their career and stuff like that. You can hear about their computational linguistics if that interests you, and then also probably more interesting to you guys is natural language processing. Also, this is a very incredible reading group this week. Would highly recommend. I'm going to be plugging away at this. Stable video diffusion. We're going to be learning about it from one of the co-authors of the paper. Going to be very cool. Knock your socks off. Yeah. And then also, finally, I'd like to plug Theory Track. This is the other half of workshops, in case you forgot, where we're going to be talking about the math and stuff like that behind it. We're going to be doing a little bit of maximum likelihood estimation and loss functions, back propagation. It's going to be much less theoretical than this week, but still theoretical enough, So with that, I'm going to hand it over to Sparsh. And yeah.
Okay, so last week we sort of just plunged into the notebooks directly, but this week we're going to introduce the concept of feed-forward networks to everyone first, so that way you guys are sort of more prepared for the architectures that you guys will be seeing in the notebooks. So this is sort of the quintessential diagram of a neural network. When you think neural network, this is sort of the default picture that you should have in your mind. And we'll go over what the parts of this mean. If you guys were in the MNIST group last week, you probably remember going over this, but we'll just go over it again so that it's absolutely crystal clear. So first off, we have the layers of our network, right? And each layer can be thought of as a vector, where the vector is just literally just like in math, just a list of numbers that you have arranged, in this case, vertically. And the way that you get the next vector is you take the previous vector, you multiply each of its components by some weight, and that gives you the corresponding number in your next vector. So that's what we have here. You take the previous layer, multiply its neurons by the appropriate weights, and that gets you the value for the neuron of your next layer. So each of these lines here, for now, just correspond to a weight. Okay. And that weight is represented by this component term, W. So right now, we just have a simple linear relationship, right? Y equals Wx. Now, if you are familiar with linear equations, you'll know that there is an extra term you can add, right? Which is the constant term. So that would be here, the bias. And if you want the full linear algebra of what exactly this means, right? We have a weight matrix and we're multiplying our previous layer by that weight matrix to generate the next layer. But you don't have to necessarily worry about this layer just yet. You can just think about it again, purely symbolically, as Wx plus B. Now, so far, this is what all of the lines represent. You multiply each of the weight of the neurons by their corresponding weights, and then add a bias, and that gets you the next value. Now, the problem is, this is sort of what it means here. You multiply each of them by the corresponding weights, then add in the biases, and that gets you that gets you the elements of your next layer, which you can see here, right? each corresponding weight, then add in the corresponding bias, that gets your numbers. Okay. So if we sort of add these layers one after the next, after the next, after the next, we'll end up with our input layer X, weight plus a bias. And then you put that as the input to your next layer, multiply that by the weight matrix, add in the bias, multiply that by the weight matrix of the third layer, and then add in the bias. But the problem with this is that we can simplify all of this down, right? Because W3 times W2 times W1 of X is just going to be some other weight matrix times X. And likewise, W3 times W2 times W1 of the biases individually, those are just going to be vectors which we can add together to create our own bias. So we can collapse all of this down into just another one, into another simple, into another linear transformation. So we still have a transformation of the form Wx plus v. Can everyone see that? Okay. So far we're on the right track, but the way that our model currently works, there is actually no benefit to adding extra layers, which means our model cannot actually model anything of much complexity because this is all it can model. So the reason that this problem arose, if we go back, is because we're just superimposing linear transformations one after another after another. So the solution to this then, just make it nonlinear. So if we just make this part nonlinear, now each corresponding input to the next layer is no longer going to be a linear transformation, and that solves the problem. Right, and that you can see as modeled right over here. Hopefully you can see the cursor. You can. Okay. Okay. So as far as this nonlinearity function goes, the sort of basic one that gets introduced is the sigmoid, which looks roughly something like that, which you can see over there. But you don't have to use that one. And in fact, in modern machine learning, we don't use that one because it's not very good for reasons we'll get into in a little bit. But as long as there is some nonlinearity in your function, it'll work fine. So in this case, we have this function, ReLU, which is just y equal to x for positive values, and it just sends all negative values to 0. So one interesting thing about this is this has linear components, right? But the fact of the discontinuity right over here, that little bit of nonlinearity is enough for it to sort of capture more complex things. And that way we can like model like arbitrarily complicated things, even with this nonlinearity function, even though this itself looks very linear. And this is actually a better nonlinearity function we found than the sigmoid, which on the surface of it looks less linear. So that's really it for just the basic feed-forward networks, right? So just going back real quick. Each output layer is generated through this process. And we can choose a bunch of nonlinearity functions. And the nonlinearity function that you'll generally go with is the ReLU function. And so with that, let's hand it over to AI ethics.
Alrighty, it's me. I'm back. So AI ethics. Y'all ever like watch Terminator? You know? Yeah. Okay. Well, that's not really what we're talking about tonight. But you know, it's just what everyone thinks about when you talk AI ethics. Quick little disclaimer up here. I am not going to do justice to any of these topics. Like this is going to be, I don't know, like 15 minutes. And you know, please, I'm begging you, like do more research, you know, think about these issues beyond just the surface level discussion we're gonna have. You know, each and every one of these is extremely important. And like, yes, you know, if you like want to do AI and like, you know, make a bunch of money, at least like give a little bit of thought to like ethics, because ethics is very good, I promise. You know, like if you are looking for any particular recommendations, the YouTube channel Philosophy Tube has a really great ethical AI video, which I think is a good starting point. I'm sure there's tons of other great resources out there. I kind of made these slides relatively recently and threw them together. So, you know, don't really have a comprehensive list. But if you're interested in learning more, please come find one of the officers and talk with us about it. So we'll be discussing a couple of main issues. We're going to be discussing data privacy, biased data, misuse of AI, and AI explainability. Those are the four main things we're going to be touching on. What we're not going to be talking about is AGI, or artificial general intelligence. That's a very trendy term right now. A lot of stuff there. We're not going to be touching on it that much. We won't be talking about like Skynet, another Terminator reference. Existential risk, long-term ethical concerns. These are other things that you'll sometimes hear in discussions. This is not our primary focus. You know, if you want to think about like the existential risk posed by artificial intelligence, you know, that's a little bit like longer term and, you know, something that we don't really gear our workshops around. We also won't be really discussing much of startup culture, how I wish I'd played freshman football, and a whole myriad of other things that I could yap on for hours about. All right, so kicking things off, data privacy, right? AI data privacy is not that different from like normal data privacy, right? The long story short of it, don't use people's data that they don't want you to use. And, you know, if we're getting data, like get it ethically, you know, don't go around like stealing data and like rifling through people's trash, you know? There are some extra things specifically related to AI that do merit mentioning, right? The ethicality of like using these huge data sets that are used to train like ChatGPT and Stable Diffusion that are just scraped from the internet has led to quite a lot of debate, and for good reason. This is an area of ethics that in a lot of ways is like brand new. In some others, it's really not that new. But a lot of ways it is brand new. You know, these are things that we've never really had to reckon with as a society before. You know, so I'm going to be going through a lot of stuff in this talk. Most of it's going to be oversimplified, all right? Like, do not take this as gospel, and I'm going to probably do a pretty bad job of explaining most of it. But it's okay, we're going to speed run it anyway. You know, so when you're doing huge data sets, there's like a lot of questions that you should be looking into, right? First of all, like, what does it mean to like ethically obtain data, right? Traditionally, ethically obtained data is like data that you get like explicit like permission to use, right? But you know, the way these huge data sets were formed was they just went through and they trawled the entirety of like the internet, right? You know, is it okay to assume that out on the internet means okay to train on it, right? The argument for that is it's like, well, you know, anyone can go on the internet and look up like, you know, a picture or like look at like text that's on the internet and learn from that. But that's with a human, not like an AI model. You know, that's a different question. You know, who knows? You know, if you were like unaware that this could even happen, right? Like say, you know, you're someone who like makes like YouTube videos, and then you're like, if I had known I could have like been scraped, I would not have put these YouTube videos out. You know, that doesn't quite seem right. You know, also like how plagiarizing is this AI, right? This is going to talk, you know, I'm talking specifically about like generative like AI art models. Jordan is not here right now. Ask him more about this. He is much better about this than I am. You know, like for Stable Diffusion, sometimes you'll hear people say that, you know, it's ripping pieces of art and like just combining them into like some like stew at the end. It's not quite a completely fair like representation. You know, you're trying to map the statistical distribution of what is like a meaningful image. And again, this is butchering generative AI. Talk to Jordan about it. We have great reading group slides and talks about it recorded up on YouTube. You know, but, you know, and so figuring out like, you know, how do we like attribute credit with AI? And like when we're dealing with these huge data sets, at what point does it cross the line into like plagiarism, right? And also now that the AI is made, what the hell like do we do, right? It would be one thing if we were having these academic discussions beforehand, but we really were not, like, this is not something that like had like a lot of thought until like it became evident it would be an issue, right? And that does legitimately change the dynamic. You know, these tools are out there. They're probably going to continue being used. And so now we need to retroactively as a society have discussions about these technologies. And these are all issues that like are not settled by any means. You know, I encourage you to go out and hear it from a diversity of viewpoints, because this isn't like me standing up here and being like murder is bad. This is me standing up here being like, this is an incredibly nuanced issue that a lot of people have different feelings about, right? So another big concern that we're going to touch on is biased and bad data, right? This isn't exactly a new concern. Statisticians have always had problems with bad data. But, you know, with AI and modern AI in particular, to oversimplify it, you give the AI a bunch of data and it looks at that, learns from it, and picks out a bunch of patterns, right? It will reflect all of the patterns in the data, including patterns that you might not want, right? And there's two main ways that this bad data can come about. Bad methodology and what I like to call a reflection of ugly truths, right? So first off, bad methodology. This is relatively simple. If you've ever taken a stats class, you probably know exactly what I'm talking about. You know, like think like asking bad questions. If I go up to you and say, you know, would you say that super cool Jordan, who does all sorts of dope stuff for ACM AI, is better than Stinky Jackson, who barely does anything? That's a pretty biased question to ask, right? And that's not going to get you good data. You know, and this, you know, there's a whole host of other ways, you know, like I said, if you take a stats class, you're going to learn all about, you know, the bad ways of doing it and like how, you know, you can do things in unintentionally bad or biased ways, right? And as we discussed, biased data means a biased AI, right? And if your AI is biased, you really got no one to blame except for yourself, right? You can blame the data, but the data doesn't really take personal responsibility, right? And the other thing that, you know, is this is a bit newer, you know, is the sort of like ugly truths of the matter, right? A lot of times we need a lot of data that we can really only get from existing sources, you know? Like it used to be you could have like a control set and like, you know, like you would have like a control set and then, you know, you would like have like, you know, your actual like test and trial group, right? But for like some of the stuff that we do, right, you need this sort of data that can only be generated on like a monumental societal scale, right? Think ChatGPT, you know, in case you're unaware, ChatGPT was trained on like all of the internet, right? And when you're pulling this data, it is a reflection of like the society we live in, right? And sorry to like spill the beans, society isn't 100% perfect, you know? And so if we're pulling our data from, you know, a source that is basically like our entire like human psyche, we might get some imperfections and biases reflected, right? ChatGPT was trained on all of the internet. I don't know if you guys know this, the internet can be kind of racist sometimes, you know? And so, you know, you're going to see that reflected in the data that, you know, you pull, right? And the other thing, you know, like that's really important to understand is that there's not always easy ways to correct this, right? ChatGPT was trained on an astronomical amount of data, like so much data you could not even begin to like fathom it, right? Like it's just a completely like inhuman scale. And so like it'll be completely impractical to filter out everything that's racist, right? And also this begins to get into like some bigger questions of what do we want to like filter out, right? You know, like we probably want ChatGPT to have like some understanding of like racist viewpoints, right? But we don't want it to be legitimately racist, you know? Like what data do we want in there, you know? Or you know, think on like a smaller scale, right? One classic example that you hear talked about a lot is, you know, resume like rating AIs, right? Companies will deploy an AI to like help them screen people for, you know, applications. And it turns out, you know, historically, if like for like a software engineering position, men have been favored over women, right? And so when you tell it like, hey, here's everyone who's ever applied to Amazon in the past 20 years to be a software engineer, it might end up being biased towards, you know, men, right? But there's not always an easy fix to things like this, right? You know, like what exactly is your end goal with this AI, right? What if, you know, like, okay, say you have an AI that's like biased against women and it's reviewing resumes. Well, what do you want it to do? Do you want it to get a perfect 50-50 split? Well, okay, well, what if there's like, you know, in general, there tend to be more men applying than women because of, you know, a variety of factors. You know, STEM is not, you know, as welcoming to women as it is to men. So, okay, so do we want it to just be reflective of the pool of applicants? Well, you know, what if, you know, like if you're a woman in STEM, right, you might be, you know, more qualified because it takes a lot more like, you know, to break in as, you know, a woman in the field. Okay, so do we want it to be like completely reflective of like the gender ratio? You know, should we even be introducing gender at all, right? But then also you get like the issues of, you know, even if you remove like the gender of the person, there's still ways to like pick up on it, right? You know, like in the case of the Amazon hiring AI, it was discriminating against like women-only schools, you know? And like, yeah, okay, so then you remove that, but it can keep on picking out these patterns, even if we as humans have done our best job to like remove it, right? You know, and so sometimes it can almost seem like the easiest way to fix it is try and fix the fundamental issues with our society. That's a little revolutionary and like out there. We're not going to delve into like that much detail. But this is something very important to be aware of, that when you're making an AI, you know, like you could make an AI that's a perfect representation of the status quo and like the society we live in now, but hopefully you will be able to make an AI that is, you know, even slightly better and, you know, just, you know, a slightly better, you know, like, you know, a little bit more progressive, right? You know, and again, this is another thing where there's a lot of open questions. It's very hard to, fully talk about. Next up, a little bit easier to grasp, hopefully, misuse of AI, right? You guys are all good people. You can make AI do bad things, right? You can make AI make deep fakes. You can create like drone swarms, you can convince me to like send my life savings away to Nigeria, right? There's a whole bunch of bad things that you can do with AI. Just please do not do these. If you're unsure, if you are doing something and you're like, my grandma would be disappointed in me, just don't do it, right? There's a whole bunch of bad ways that you can use AI. Just like, don't do it. You guys have hopefully good moral compasses. You have your head screwed on straight. You have a pretty good understanding of what it means to be a good person, and, just do good things. And worst case scenario, err on the side of caution. If you aren't 100% sure, maybe don't, maybe don't deploy the AI that you don't fully understand what it'll do, because, well, once you make an AI, like once you take it out of the bottle, it's like a genie. It's very hard to put back in. And finally, we're going to talk a little bit about AI explainability, right? We're increasingly using AI for things that we have historically used humans to do, right? And this is unique in that the things that we're replacing it with, it used to be you would never like have a machine do, right? It used to be you would never have like a machine write something for you because machines were never any good at it. But now with large language models like ChatGPT, they are good enough to write pretty good, like things. And so this can be good for efficiency, but modern AI are incredibly complicated, right? Like I think GPT-3 has like 700 billion parameters or something crazy like that, right? So this means for all intents and purposes, these AI are like black boxes. We're feeding in something into one side and out the other side is coming out something. And we, except in like the most simple like cases of AI, have no idea what's going on inside of there, right? We know it's a bunch of linear algebra that like, based off of like the probabilities and like what we like know is probably going to do a pretty good job. But beyond that, you don't have like any of the specific reasoning, right? Like if I write something, I can like explain to you like what my thought process was, If I'm writing a response to my homework, I'm like, okay, I'm answering this question and I'm going to think about these factors and I want to talk about these points and, I'll be able to tell you what it is. But with AI, we are not necessarily guaranteed that, and a lot of times, you might ask yourself, well, why I can just ask ChatGPT how it arrived at that answer. And that is also not 100% accurate, I'm sure you guys have had like the occasions where you've copied and pasted your homework problem into ChatGPT, gave you an answer you didn't understand. So you're like, explain to me how you got to this point. What it's doing there is it's not actually, we're not 100% sure that it actually is explaining what it did to get to that point. Because technically, like on a technical level, what's happening is it generated this answer, and then based on, oh, did the slides go out? Oh, there we go. And then based on that answer, right, you then ask it, can you explain to me? It looks at that answer, and what it's probably doing is just looking at it and being like, okay, how can I explain how I got here retroactively, right? So we don't really have good insight into what exactly is going on inside of the AI, right? Now, again, this is the age-old like philosophical, how do you know anyone else is conscious other than you? But, with AI in particular, it's not human, and that's another layer of removal. It's kind of hard for us to, reckon with. And this is also important, not just for me cheating on my homework and not understanding the math that it does for me, but it's important for things like, if you have a medical AI, right? If you have a medical AI and it like looks at you and it tells you, you should get like, this surgery to like, I don't know, like I think you have cancer in this part of your body, and it can't tell you why, would you go through with that surgery, right? Like how accurate does AI need to be before we're willing to trust it, even if we can't explain it, Like if, an AI is less accurate than a human doctor, you probably wouldn't trust it. What if it was just as accurate as a human doctor? What if it was like a human doctor is like 90% accurate and the AI is 98% accurate, right? That's still a like 2% chance. It's still a pretty decent chance that you're getting surgery for nothing. But, it is better enough than a doctor that it might warrant looking into, and this is something that is very, again, open question. This is something we as a society have to come to a reckoning to and fully understand. If you're interested in learning more about this, we're going to have a great reading group, I believe week 5, about transformer explainability. Basically, and when ChatGPT is generating stuff, what the hell is it looking at? And that's going to be one of our lovely projects officers, Will, who will be here for this. And so that's a very brief cursory overview of a lot of these pressing ethical issues. Again, please do more research. Most of what I talked about is not an open and shut case. It is an open question that you should be looking into, hearing from a variety of diverse viewpoints, and coming to your own conclusions with. Thank you for the time. And now we're going to be going into our more like normal format where we're going to be, breaking up into small groups. We'll probably do something similar to last time. I'm guessing most of you guys are on the MNIST notebook. So if you're on the MNIST notebook, please move forward. We don't have a ton of officers, so we want you as dense as possible. So please move forward. The middle will be like MNIST, and then if you still want to go over like the beginner notebook and you don't have that much exposure to Python or any of these libraries, go to that side. And then if you are already done with the MNIST notebook and you're like easy peasy, I'm going to be on to Sci-Far 10, go over there. But please move forward. Don't be sitting in the back. Move forward. We want to be able to get to as many people as we can.